Today we're going to look at an application of normal distributions. One of the reasons why normal distributions are so important is that they can be used to model many real-world situations. For example, standardized exams given to a large population are often approximated quite well by normal distribution. For example, the distribution of ACT mathematics scores can be approximated very well with a normal distribution that has a mean of 19.55 and a standard deviation of 6.5. We're going to use this model to compute some different probabilities and inverse probabilities. So we're going to be using a calculator in this course or other computer software to compute values of the normal distribution and inverse normal. So when I'm doing this on my calculator, probably the first thing I'm going to do is just take the 19.55, hit the store button, which is, see the on button down here in the lower left, the STO button gives us the arrow, and then we're going to store that in alpha, that's the green button up here in the upper left, and then I'm going to put EOM for mean, so that's the above the divides key, so hit divides. So that'll store that as EOM. So anytime I want the mean, I can just type in EOM. And similarly, I'm going to take 6.5 and store that as alpha S. Notice these things are in alphabetical order, so it looks like S is right there above the LN button. So now we have the mean and standard deviation. We want to find the probability that a randomly selected student taking the ACT will score between 19 and 25 on the mathematics portion of the ACT. Well, we will go to second distribution, and really everything we need for normal distribution are these first three right here. If we want to see the graph of the normal distribution, we'll do the normal PDF. If we want to compute probabilities, however, we're going to use the normal CDF. And if we need an inverse probability, we'll use inverse norm. We can also right arrow to draw, and to do shade norm will also graph and shade for us. So for example, let's start with shade norm. So if we do shade norm and we give it the lower 19, upper 25, commas in between, and then the mean, which I've got stored, remember, as EOM, and the standard deviation, which I've got stored as S. Or you could actually type in 19.55 where I have the EOM and type in 6.5 where I have the S. This is going to draw this normal curve and shade it. Okay. Now we might want to change the window just a bit. ACT scores run from 0 to 36, so let's go from 0 to 37, from 1 to 36 actually, so we'll go from 0 to 37, and let's go up a little bit here to well, actually we don't have to go up, let's go down 0.3, and let's put a little bit more room at the bottom of the screen to maybe 0.06. Okay, so let's see if we can do that same thing again, see if it looks a little bit better for us. So we're going to go to the draw menu, shade norm, actually it was the distribution menu, then right to draw, shade normal. I could have just done second in, actually you know what I can do? I can do second enter, and that'll bring up this previous thing. There's a little bit better. It doesn't quite cover up as much here. In fact, I'd like a little more dead space to cover this up. But anyway, we have the area. 0.332831. Okay, so we can pull that over here. Actually, I'm gonna one more time. I'm gonna give a little bit more space at the bottom. How about just 0.1? And do that. Just hit enter, and it'll do it again. There we go. Now, whenever I get the numbers down here, it won't cover up any of my drawing. So there's our drawing there of our normal curve. In fact, we could even come in a little bit lower. That's 0.1 there. But I'm just gonna leave it like that. That'll be fine. And so now we've found out that value. By doing that drawing, okay, by doing the shade. We can also find it without shading it. If we want to do probabilities, we want to just go here and go in normal CDF, and we tell it to go from 19 to 25 with our mean, M, and our standard deviation. It should be M. And our standard deviation, S. And there we get the value there. Okay. So let me type that over here. That is normal CDF 19 to 25 and then MS. And before that before I even started, I took 19 and stored it as not 19, what was the mean? 19.55 and stored it as M, and 6.5 and stored that as S. Okay. Now, let's go on to the next one. Suppose that all students scoring below 19 on the math portion of the ACT have to take remedial mathematics in courses in college. What proportion of all students taking the ACT will have to take remedial math? Well, that means we want a probability below 19. Well, on the ACT, it really should be, really only goes up to 18. You can't get a fractional score. So we want below 18 or below. So what we can do is a normal, go to second variables for distribution, number 2, normal CDF, and we want to go up to and including 18. Really, because of what we really have to do is we're going to go to 18.5. So when we have a discrete distribution like a ACT scores, but we're going to approximate it with a normal, then you need to kind of go to where it rounds off. So it rounds off at 18.5. So we're going to go from minus infinity to 18.5. Now, the problem is here that we can't really put in minus infinity. But what we can do here is put in M minus 10s, and that always makes a pretty good estimation for minus infinity, because that goes 10 standard deviations below the mean, and that will probably give us a decent value there. Let's see what that actually is in this case. Negative 45 point something. We can go a little less, negative 46, negative 45 is okay. In fact, you can't really get a score below 1, so if we actually just put 0 here, we should be reasonably well off here. But let's just go ahead and just leave it like that. So in general, what I suggest when you're doing a normal distribution, from negative infinity, use M minus 10s, and that will will be a pretty easy way to remember that. It's something you can use. So we're going from negative infinity to 18.5 actually, and with our mean of m and standard deviation of s, whatever that is. Just be sure and store those before you start. And that gives us what we need there. So that was normal, CDF of m minus 10s up to 18.5 with our mean m, standard deviation s. And that gave us about 0.435834659, or in other words, about 43.6%. We can also shade that if we'd rather, or we'd like to. So if we go to second distribution, go over to draw, shade to normal, and again we can, well, this is going to go from the edge of our screen here probably, so let's just go to, well, let's go ahead and go what we said. Let's see what happens. Mean minus 10s up to 18.5 with a mean of m and a standard deviation of s. Okay, I should have cleared my drawing first because this one has the other stuff is still there. So let's clear the drawing and do it again. Actually, I can just hit enter. There we go. And so that's the same number there again, and we're going from, you know, really low up to about 18.5. Notice I did use that rounding off thing because of the discrete nature of the ACT scores. If I were doing this and you could get decimals and things for scores, I would actually gone all the way up to 19 if it had really been a continuous distribution. So UAFS, students scoring a 23 or higher can test into Probability and Statistics 1 without taking college algebra first. What percentage of all students taking the ACT would be able to test into ProbStat 1? Well, while I've got it here, I'm going to go ahead and clear my drawing. And we want to find again a probability, so we can go to second variables, normal CDF. Okay, and this time if they're 23 or higher, so again I'm going to go 22.5 because of the round off of the ACT thing, because it's discrete. And then we're going to go from there up to well, to infinity. Well, for infinity I'm going to use mu plus 10s. And again, this is probably overkill here, but what this does is says we go out 10 standard deviations. In theory, there is some more probability, more than 10 standard deviations above the mean and less than 10 standard deviations below the mean, but it's such a small probability that it doesn't affect the digits on, you know, the however many digits we have on a calculator. So going out 10 standard deviations away from the mean is, for all practical purposes, as good as going to negative infinity or positive infinity. And of course, we're going to the right, we'd be adding to the mean. So we give it the mean and the standard deviation, and we have our answer. We can also shade it if we like. Okay, go here, here, shade normal. We want to go from 22.5 again up to well, to infinity. Well, we'll go from mean plus 10 standard deviations. That's good enough. And give it M and S. Notice by using these letters, this is exactly what you would type pretty much every time. The only thing you would change is this number at the first. And it's this area on the right. So what we have here now is we've just computed this probability, and the way we put that in the calculator was normal CDF of where we're starting, 22.5, and again we put that 0.5 because we're rounding off because of a discrete distribution instead of putting the 23. If this is really continuous data, we would have just put the 23 there. And we want to go up to infinity, which is we're going to use M plus 10S for that, and with the mean of S, mean of M, standard deviation of S, and the calculator gave us 0.324969793, or about 32.5%. Okay, so let's do now an inverse probability. Suppose you made a 25 on the math portion of the ACT. What's your percentile rank? Okay, so this time we're going backwards. We know this is still a probability. We'll do an inverse probability here in just a minute. This is still a straight probability. So we're going to go to same thing here again. We can do normal CDF, and we put the 25 in, and we want to find the probability that it's less than 25. Okay, so we would go from negative infinity, which we're going to approximate that by M minus 10S, and we're going to go from there up to 25. Let's just go ahead and put 25 here this time, and then give it M and S. Okay, and that gives us our percentile rank, which we were at basically at the 80th percentile. Well, it'll be 79.9th percentile. Of course, remember, percentile is tells you what percentage of people scored where you are or below. Okay, let's do one more question, and this is going to be an inverse probability. So let's suppose this time we know the percentile and we want to find the score. So what is the 90th percentile for ACT mathematics scores? Okay, so this one's backwards, where we know the probability this time. The cumulative probability is 90%, 0.9. So this is where we have to use an inverse normal. And again, we're lucky because this is built in, so it's just number 3 here. Inverse normal, we put in the percentile, the percentage that's to the left, the 0.9, and then comma. Now we just give it the M for the mean and the S for the standard deviation, and hit enter, and it'll return the well, in this case the X value, which is the ACT score. Okay, and so once again, let me type that in. That's inverse. Well, actually, you can see it really well here on the screen, I think. So we'll just leave it at that. The inverse normal, 0.9 M and S, and so about a 28, 27.88 would be about at the 90th percentile. So that gives you a little example of some normal applications. This one's made a little bit more difficult because of the that we're using a normal distribution to approximate a discrete, we had to do a little rounding off. Most likely, if I give you this on the test, it'll be a continuous distribution, so you won't have to worry about that.